Now. So hi everyone, welcome to Sec 4 Math with me, Teacher Kim, on Thursdays at 8 p.m. Hi Isabel. I hope you're having a great week. And so without further ado, let's begin. Okay, please remember to be patient and understanding. Always remember to observe gracious and respectful behavior. And of course, don't be afraid to ask any good and relevant questions. Okay, so if you face any technical issues, our kind moderator and lead, okay, is here to help you today. Otherwise, if you have any other questions, feel free to send them in the chat anytime during the lesson, okay, and I will answer them accordingly. Okay, so an overview of what we will be doing today. Today we'll recap a bit of what we did last week, okay, where we learned about the 5 key values for any set of data. And we also learned about cumulative frequency curves, right? So today we will build up upon that from last week, and we will learn about discrete data as well as the box and whisker plot. Okay, so how to look at the box and whisker plot and how to draw one of your own. Okay, so let's do a recap first. What is the median? The median is the value of the data in the middle position after it is arranged in ascending order. Okay, so always smallest to biggest. Okay, I hope you guys are clear with what ascending means. Okay, and for lower quartile is the middle value in the set of values in the lower half. Okay, and finally upper quartile, that is also the middle value, but this time it is from the set of values in the upper half. Okay, is this clear to everyone? I hope you guys remember this from last week. Those of you who missed last week's lesson, I highly encourage you to watch that first before you try the bubble questions we have for you here today. Okay, because you will need that information to work on the questions we will be dealing with today. And then the next set of key values we learned about is the interquartile range. Is everyone able to hear me well? Okay, so interquartile range, to calculate the interquartile range, we take the upper quartile value minus the lower quartile value. Okay, and for range, we take the highest value or the largest value minus the lowest value. Okay, any questions here? These are just the definitions that we learned from last week. I hope all of you are clear with this. Okay, now so then we also learned about percentile. Okay, so percentile is when we take a set of data and we split it into 100 parts or 100 percentages. Okay, so each percentage represents a particular value. So the median, remember, is the middle value in our entire set of data from 0 to 100. Okay, so that middle will be the 50th percentile. Okay, so in the lower quartile is the middle value in our lower half. So when we cut, so from 1 to 100, we now have two halves, right? From 0 to 50 and 51 to 100. So the middle value in that lower half will be the 25th percentile. And the middle value in the upper half from 51 to 100, that will be the 75th percentile. Okay, so to find our interquartile range, we are taking the 75th percentile minus our 25th percentile value. Okay, and for range, it's always our highest value, so our 100th percentile minus that first percentile. Okay. Yeah, so over here we have our first worked example. We have a set of data given to us. Okay, first we are asked to find the median. So remember the median, do we just immediately take this set of values and find the middle? Or what do we need to do first? Think about the definition. Very good, Denise. We always remember, look at the definition again. It is the middle value, but after everything is arranged in ascending order. Okay, so that is always our first step. Our first step will be to rearrange the numbers from lowest to highest, right? From 0 to 100%. Okay, so the smallest value here will be 8. Second value is 13, 8, 13, 19, 21, 24, 31, 36. Okay, so these are my rearranged set of values, and now I want to find the median. So median, I have 1, 2, 3, 4, 5, 6, 7, 7 individual pieces of data. Which one will be the middle piece? If I have 7, okay, one way I can do it is I can take 7 divided by 2. That will give me 3.5. So 1, 2, 3, and the one after that. Okay, so this will be my median. The other way, I know some students prefer the old school method, okay, where you just count, right? You cross 1, 1, 1, 1, 1, 1, and you realize 21 is in your middle. Okay, so there are two ways. Either way, you can go about it. Okay, but of course, the calculation method might be a bit easier. Okay, since when you have bigger pieces of data, let's say 20 or 30 numbers, it might be easier to just calculate where is the middle position, right? So 7 over 2 divided by 7 over 2, that will be 3.5. Okay, so our median equals 21. Okay, now next, now that we have our middle value, where is our lower quartile? Okay, so lower quartile means now we have this set of values here, which is our lower half. Okay, and this set of values, which is called our upper half. Okay, so yellow is lower half, green is upper half, right? Very good, Alicia. The median is the middle number in when middle value in the set of data from in ascending order, right? So first you must always arrange everything in ascending order. Ascending means lowest to highest, okay? Okay, so now lower quartile. What about lower quartile? What does it mean? Can anyone tell me the definition of lower quartile? Anyone remember the definition? Okay, so lower quartile will be the middle value, but this time, hi Fion, very low. Very good, Denise, the 25th percentile, but what is the definition? Okay, that is how we calculate the lower quartile, but what is the definition of the lower quartile value? How do we find the lower quartile value? Did anyone take down notes from last week? Okay, so the lower quartile value is the middle value in what half? The middle value in the lower half. Okay, so remember this one, this part here is our lower half, and the green one is our upper half, right? Because we found that 21 is the middle, right? Is the center. So then after we remove the center, it's like if you imagine you have a bar of a string, okay, that's this long. Then you cut it in half. So now you have two pieces, right? Two halves, one half and one half. So if this part is 0, then 0 to this portion, okay, will be your lower half. And this portion will be called your upper half. Okay, then in your two halves, so in this half, okay, now we only look at this half. Okay, this is your lower half. The lower quartile will be the middle value in this piece. Okay, that middle value. So what is the middle value in our lower half? Can anyone tell me? Anyone want to try? What is the lower quartile value? Very good, Alicia. 13. Okay. Yes, very good. Okay, 13. This is our lower quartile. And what about our upper quartile? What is the upper quartile value? Very good, Alicia. Oh, there's two Alicias. One Alicia Ng and one Alicia T. Okay, so very well done, both Alicias. Okay, so the upper quartile value will be 31, right? It's the middle value from our upper half. Okay. Okay, then now how do we find the interquartile range? So remember, the word inter means in between. So in between our quartiles. Right? So in between our two quartiles, we have two quartiles, right? One lower quartile, one upper quartile. So how do we find the value? In between these two, we take our upper quartile minus our lower quartile, and that will give us 31 minus 13, which will be 18. Okay, just in case any of you are wondering, okay, this line is not compulsory, okay, but you do have to show the workings from here and here. Okay, so you can just put interquartile IQR equals 31 minus 13 and then your answer. Okay, and finally, last one, we have range. So range is the highest minus lowest, highest value minus the lowest value. So what is our highest value? What is the largest value we have? That will be 36, right? And the smallest value we have is 8. Okay, so we have 36 minus 8. So we have the range 28. Is this clear? Any questions? Okay, this is a recap from last week. Okay, now not really from last week. Okay, this is a recap of how we find the key values, this time in a set of listed data. Okay, last week we were doing cumulative frequency curve. This one, we are given pieces, individual pieces of data that we first need to rearrange. Okay, now, second example, this time we have 1, 2, 3, 4, 5, 6 numbers. Okay, so to find the median, again, my first step is to rearrange from lowest to highest. Right, so let me do that. 1, 3, 5, 7, 8, 11. 1, 2, 3, 4, 5, 6. Yes, okay, so I have all 6 pieces of data. And now to find the median, so if I do the calculation step, I will have 6 divided by 2. That will give me 3, right? So that means 1, 2, 3, 1, 2, 3. Okay, so always remember when you have an even number of data, the median is always in between. Okay, is that clear? The median lies in between. Okay, so to find the value in between 5 and 7, we take the average, right? So we take 5 plus 7 over 2. That will give us 12 over 2. So our median is 6. Very good, Denise. Well done. Okay, is this clear? So always remember, when you have an even number of data, you must find the average, okay, between two numbers. Now, lower quartile. So again, we have two halves, right? Our data is now split into two parts. One part is called the lower half. The other part is called the upper half, right? So what is our lower quartile value? Our lower quartile value will be the middle in the lower half. Okay, so that will simply be 3, right? Okay, and very good, Nigel. Well done. What about the upper quartile? What about the upper quartile value? Well done, Alicia. Well done, Nigel. Very, very good. Okay, the upper quartile value is the middle value in the upper half. Okay, so that will be 8. Okay. Now, interquartile range, again, very straightforward. Okay, this time I won't write the whatever is unnecessary. Okay, so IQR equals 8 minus 3, right? Upper quartile minus lower quartile. So that will give me 5. And for range, I take the highest value, which is 11, minus my lowest value, 1, to get a range of 10. Very good, Nigel. Well done. Okay, so Denise asked, is it possible to do by percentile method? Okay, for this question, okay, for questions where they give you discrete data. So this is called discrete because it's one piece by one piece, right? You imagine it as you have a class of 40 students and each of those students have a different score. Okay, so it's not like last week where we have plants growing or things like that. Okay, where we can use a graph because we have smaller sets of data. So if you use percentile, let's say 0.25 times 6, that will give you 1.5. I mean, you still can do it. It's just that you have to be then you have to be very familiar with what is the percentile and what is the percentile value. Am I clear? Does that make sense to you? Yeah, okay, very good, Denise. Okay, yeah, so if you prefer the percentile method, you can do that as well. Okay, so let's say I just do median. Okay, so median, okay, maybe I'll do it in black since I use red for explanation. Okay, so median will be the 50th percentile, right? So I will take 50 over 100 times 6 because I have 6 pieces of data. Okay, so that will give me 3, which is my working here. Do you see? Okay, then but you see here, median, this tells me is the third position. The median is the third position, but it's actually not the third position, right? It's in between the third and the fourth. Okay, so this is actually the median position. Okay, so then my median will still be, so I have to look now for the value between my third and fourth. Okay, which is still, my third value is 5, my fourth value is 7. Okay, so it will still give me the same answer. You will still get the same answer. Okay, just that you need to be very familiar with which one is your percentile and which one is your percentile value. Is that clear? Yeah, okay. It's like a new age thing when you guys don't spell yes anymore. It's like just yeah. Okay, so bubble question one. A set of data is given here. Okay, now you need to find the median. You have 1 minute for this. Your time starts now. Okay, so again, remember you have 5 pieces of data. So before you go about finding the middle number, okay, you always need to rearrange, okay, because the definition is middle value in ascending order. Okay, so smallest to biggest. Okay, so always remember, okay, to rearrange your values first. So the smallest value we have will be 27, next 33, 37, 49, and 69. 5 pieces of data. And from here, now that we have rearranged, we can look for our middle value, okay, which will simply be the number in the third position. Okay, so that gives us 37. Okay, very well done. Seems like everyone is able to follow. Okay, so now that we have our rearranged set of data, 27, 33. Okay, I hope you guys are doing this on paper. So if you're doing this on paper, then it won't be so cumbersome, right? When the question like resets itself to the second bubble question. Okay, so now we have the rearranged set of data. So from here, you have 30 seconds to find the lower quartile. Okay, so time starts now. So again, this is your median. Okay, so where is your lower quartile? Okay, so this set of values will be known as your lower half. Okay, then the lower quartile value will be, I see a lot of people chose option 2. Why is it 33? Okay, so in your lower half, you have two values, 27 and 33. So you want the middle is, so if you have two lampposts, let's say, okay, one lamppost here and one lamppost here. Where is the middle of these two lampposts? Will you say it is this lamppost or the other lamppost? The middle will be where my face is, right? Okay, so we need to find this middle value here, okay, in between the two values. So that lower quartile will actually be equal to 27 plus 33 over 2. Remember, we need to find the average, okay, of two values. Okay, so this position, this is our lower quartile. Okay, is this clear to everyone? Okay, so that is how we get the value 30. Okay, does anyone have any questions? Please feel free to let me know. Okay, now next one, upper quartile. Okay, so again, I'll rearrange the values for you. 27, 33, 37, 49, 69. And we found that our median is here. Lower quartile is here. So where is our upper quartile? Okay, 30 seconds again. Your time starts now. Okay, remember, identify your upper half first. Okay, so middle value in the upper half. So your upper half will be over here. Okay, then what is the middle value? is the middle value in your upper half? Okay, so very well done. Okay, so for the middle value in your upper half, you have two values, right? 49 and 69. So to find that middle, we will be taking the average of these two numbers. Okay, so again, 49 plus 69, and then we divide by 2. That will give us 59. Okay, option 2. Very well done this time. Okay, so that is our position here. This will be our upper quartile. Now, okay, so I found my median to be, sorry, just give me a minute. Median is 37, lower quartile, okay, 37, lower quartile. Okay, so just to let you know, this you can't actually note. So in your answers, right, when you're writing in school, you can't actually put LQ. Okay, LQ is just me being lazy. Okay, so don't write LQ when you're presenting your solution. Okay, because it's not a mathematically accepted term. Okay, you need to write out the term properly, lower quartile in words, okay, full words. Okay, so the lower quartile value is 30 and our upper quartile value from the previous bubble question is 59. Okay, so this time we are asked to find the interquartile range. Okay, you have 30 seconds for this. Your time starts now. Okay, so remember, interquartile range. You're finding the interquartile range. Okay, so just break down what the word means. What does the word inter mean? And what quartiles do you have? So inter means in between, right? Between something. Okay, then between quartiles, you have two quartiles. You have one upper and one lower quartile. Okay, so what is between these two values? Very well done. Okay, so the interquartile range, to calculate that, we will take our upper quartile value minus our lower quartile value, okay, to give us 29. Very well done. And finally, our range. Okay, so again, let me write out all the set of data we have found. So median 37, lower quartile. Again, please remember, don't write short form like me, okay? If you're going to present your solutions in school, remember that, yeah? I hope you're hearing me. And interquartile range will be 29. Okay, so these are the key values we found from the previous four bubble questions. Okay, so now you are asked to find the range. You have 30 seconds for this again. Your time starts now. Okay, so how do we find the range? Okay, so what does range mean? So let's say I am teaching a class of 40 students, okay, and I have students that scored from 10 marks to 90 marks. So what will I say the range of marks is? Do I say that they all their scores ranged from, what will I say? Their scores ranged from 10 to 90, right? So that range, that in between space will be the difference between my best performing student, okay, which in this case is 69, and the worst performing, which is 27. Okay, so the difference between these two is 42. Okay, is this clear? Okay, very well done. It doesn't seem like anyone has any questions, so I will keep going. Okay, so let's recap a bit on number lines. I know it's a lower sec topic, okay? So some of you might have forgotten what number lines are. Okay, so it's basically numbers on a line. Okay, but how do we actually draw a number line? So we usually have 0 in the middle, okay, depending on your data. Okay, and then we will indicate our numbers 1, 2, 3. So positive, or the larger, as we move to the right, the numbers always get larger, right? And as we move to the left, the numbers get smaller. Okay, I hope everyone remembers this. Something like your x and y axis, right? And also another key point when we are drawing a number line is that the spacing between our values, they always have to be equally spaced. Okay, so I'm doing this freehand, so of course it's not uh, properly done. Okay, but when you are actually drawing a number line in your exam, you need to use your ruler and make sure that every unit, okay, in this case is 1 unit apart. Okay, so every unit is equally spaced. Okay, so if it's 1 cm in between, then you have to make sure it's 1 cm every time. Okay, not some 1 cm, some 2 cm, some 1.5 cm. You won't get the mark that way. Okay, so why number lines? Because number lines will be needed in the next part of our lesson, okay, which is box and whisker plots. Okay, so box and whisker plots are generally used for summarizing data. Okay, so if we want a brief summary of a set of data, then we use the box and whisker plots. Okay, however, it is unable to provide information on Okay, so what do you guys think? So when we have a cumulative frequency curve, right? We have very specific values, or when we have discrete data, when we have a set of discrete data, then we have very specific values. We can say like, oh, this student got this score, that student got that score, right? But when we are summarizing data, we won't have the exact values. Okay, so okay, so what that means is that we don't, sorry, oops, okay, we don't have information on the cumulative frequency or percentiles. Okay, we can only work backwards. So we can only say after we are given the data, then we say, oh, this median value is the 50th percentile. This lower quartile value is the 25th percentile, and not the other way. Is that clear? Is everyone is everyone able to, you guys are very quiet. So if no questions then I just assume you guys understand, okay? Yeah, so however, the good thing about a box and whisker plot is that it provides us a visual representation of the spread of data. Okay, so I will explain this shortly. I keep seeing that I'm disconnected. Is everyone able to see me and hear me? Okay, so we have a set of data here. Okay. Okay, that's good. Thank you, Isabel. Yeah, so we have an example of a box and whisker plot here. Okay, so why is it called box and whisker? I'll just briefly go through first. Okay, obviously we have our box. Okay, so this part, okay, in yellow is called our box. And these two lines are called our whiskers. Okay, so box and whisker plot. Okay, and all the lines on this plot represent a specific value. Okay, so this first line, okay, all the vertical lines, yeah, okay, all the vertical lines represent specific values. The first line from the left, okay, that will represent our lowest value or our smallest value. Okay, so the 0 percentile. Okay, and the whisker on the other end, that will be our highest value, okay, or our 100th percentile, right? Okay, then now onto our box. So the first line from our box, that will be called the lower quartile. That will be our lower quartile. And of course, the other end of our box, that will be our upper quartile value. Okay, then can anyone tell me what is the value in between our lower quartile and upper quartile? Any guesses? Very good, Denise. Very educated guess. Okay, the median. Very well done. Okay, so these are the key values that you will need, okay, when plotting your box and whisker plot, or if it's given to you already, then to reverse engineer it and understand, okay, your box and whisker plot. So this past few years, okay, Cambridge switches around. So sometimes they give you the box and whisker plot and then they ask you to explain the values, or sometimes they ask you to draw the box and whisker plot. Okay, I think because over the years they realize that students only practice drawing and then they don't understand how to work backwards. Okay, so yeah, so nowadays they switch around. So it's important for you guys to be familiar with it both ways as well. Okay, so we have our set of data here. So an example of how to draw a box and whisker plot. Okay, so first things first, same thing, I always rearrange. Okay, so we rearranged it earlier. So there's 27, 33, 37, 49, and 69. Okay, so so I will start by drawing my number line. Okay, maybe I'll do it in blue. Okay, so okay, so start by drawing your number line. Okay, so I have numbers. Let's say this is 70, 60, 50, 40, 30, 20. Oh no, cannot. Okay, let's see. Oh no, I can't. Oops. Ugh, okay. Let's plan this out. So 70, 60, 50, 40, 30, 20. Nice. 27. Yeah, okay. Yes, that works. Okay, so I have my number line. And why I want so many lines in between my data is because I have weird things like 27 and 33, right? So it'll be better if I have more boxes for that so that I won't be in between the boxes. Does that make sense? Okay, so now that I have my number line, I can start plotting my values, right? So 27 will lie, okay, I'll do it in blue. So 27, 25 is here, so 26, 27. Should I label 27 in red? Will that be clearer for you guys? Okay, 27, 1, 2, 3, 33, 5, 6, 7, 37, 49, and 69 over here. Okay, so I have my key values arranged. Okay, then I can start by drawing all my lines. So let's say here, 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 and here. Okay, so I have my key values labeled. Then I start by drawing my box. Okay, so remember the box is always the lower quartile to upper quartile. Okay, so that will be here, 2. Oops, sorry, no. Oh, no. This is the set of data. Sorry. Okay, let's recalculate this. Our median is here. Lower quartile, sorry, is over here. So lower quartile, just now we found the value to be 30, right? Upper quartile is, what was it? 59. Okay, so sorry, we need to find the proper values. So this shouldn't be here. Okay, this also shouldn't be here. Ugh, why cannot erase? Okay, let's ignore that. Okay, so sorry. Okay, so we need to label, okay, the lowest value. Okay, remember our 5 key values: our highest value, lowest value, lower quartile, upper quartile, and our median. Okay, so these are the five things you need when drawing your box and whisker plot. Okay, so highest value 69, lowest value 27, lower quartile 30, upper quartile 59, and median 37. Okay, so these are the five values we will actually need. So 27, 37, 30 over here, 59 over here, okay, and 69. Yes, okay, so then now we can really draw a line. Okay, so lowest value, lower quartile, median, upper quartile, and highest value. Okay, then remember lowest quartile to upper quartile, there is a box. Okay, so I join my lines. So now I have my box. And to draw my whiskers, I just draw a line connecting my box to the highest and lowest values respectively. Okay, is this clear? So sorry, I had to redo that a little bit in the middle. But is this clear? Any questions? Yeah, okay. Thank you, Denise. Okay, so now if it's clear, okay, then we can go on to bubble question 6. So now that you understand what a box and whisker plot is, okay, you guys will have to practice going backwards. Okay, so find the range of values. Okay, find the range of this set of data. Okay, so we are given the box and whisker plot drawn here for you. Okay, so find the range. You have 30 seconds for this. Your time starts now. Okay, so remember to find the range. We always take the highest value minus the lowest value. Okay, so identify these two key values in your box and whisker plot and calculate. Okay, so what is the highest value? What is the lowest value? Hi Winnie, nice to see you again. I think it's 5 bubbles if I'm not wrong. Yeah, it should be 5 bubbles. Okay, so hi Winnie, yes, hi. Okay, so the highest value will be over here, right? This is our highest value, and this line represents our lowest value. Okay, so to find the range, we are looking for this distance. Oops, I thought I was in highlighter mode. This distance. Okay, so we will take 30 minus that lowest value, which is actually 14. Okay, so 30 minus 14, that will give us 16. Okay, very well done. Okay, now bubble question 7. Okay, group of students will ask how long they took to travel to school. Again, we have this box and whisker plot. Okay, and this time you are asked to find the median traveling time. Okay, so what is the median value? Okay, 30 seconds again, your time starts now. Okay, so where is the median in a box and whisker plot? Okay, so identify the correct line and then look at the corresponding value on your number line. Okay, I keep saying okay. Very good. Okay, very well done. Yeah, so the median is actually represented by that center line in our box, right? It is inside. The median line is always found inside your box. Okay, so this value over here will be 21, 22 minutes. Okay, very well done. Now, okay, bubble 7, 8. Yes. Okay, same question, but this time the interquartile range. Okay, 30 seconds starts now. So interquartile range, to find the interquartile range, the formula is to take your upper quartile value minus your lower quartile value. Okay, so what are these two values? You need to find these two values before you can calculate your interquartile range. Okay, and time's up. That was very fast. Well done. Okay, so upper quartile is represented by the upper box, okay, upper line in our box, upper quartile, and this is the lower quartile. Okay, so we are finding the range, remember range between these two values. Okay, so 25 minus 16, 17, 17.5. Okay, so 25 minus 17.5. Oops. That will give us 7.5 minutes. Hope this is clear. Okay, and I hope all of you had time to answer. I see almost half of you didn't key in your answers. I hope it's not because you ran out of time. No, really, what happened? Okay, so I worked example 4. Okay, the box and whisker plot shows the monthly incomes of families from town A and town B. Okay, so now that you guys have mastered reading one box and whisker plot, now you need to be familiar with comparing between two boxes. Okay, so how do we go about comparing? In which town are the families generally more affluent? Okay, so when the question says something like generally, very good, Denise. Okay, generally more affluent, what key value will we look at? Okay, so let's say remember I have 5 sets of key data. I have my lowest value, highest value, median value, lower quartile, and upper quartile. Correct? So from these 5 values, which one will tell me the general what do you call it, performance? Which key value? So imagine if you have 10 scores, okay, 10 scores from 10 different students. What would you use to estimate, okay, between the two groups? Very good, Denise. Well done. Okay, we will use the median. Okay, so that is the first key point I want you guys to learn. Okay, when you are comparing general or overall performance, we use the median. Okay, so we need to look at the median between these two groups. So the median of town A is here. That will be this value, 4,500. And the median of this town B, 6,000. Right, so who is generally more affluent? In which town? Town B. Okay, now find the interquartile range for each town. Okay, so interquartile range for each town. Okay, so actually when you're presenting your answer, you can't just write town B. Okay, maybe can I write my answer here? So in which town are the families generally the more affluent? Families from town B are generally, okay, so I will have to write this out because I want you guys to learn how to explain your answer. Okay, this is very, very important. If you look at your TYS, Cambridge is definitely going into the explain route. Okay, there are more, even last year's, especially last year's paper, okay, on the past 3 years actually, they have a lot of explain questions. Okay, so it's no longer just about like plugging in your formula and then finding the answer. Now they want you to really explain and understand what you are doing. Okay, so why do we know that town B is more affluent? Because affluent since the median. Okay, so you must state the measure, okay, the mode of measure. So what are you using as your comparison? Okay, you are using the median. Okay, so you need to answer the question by saying town B, and then you need to state what your mode of measure, okay, how you are comparing these two sets of values. Is $6,000 higher than the median in town A? Okay, so if you want to be a bit more specific, like I usually encourage my students to do, okay, you can state in the values as well. Okay, so that will just give you an extra, like, I really know my stuff. Okay, like really like an additional proof. Okay, not just like, oh, because I compared the median and then you answer. Okay, I know some schools are a bit more flexible, but some schools really want your the teachers really want you guys to write everything out, okay, clearly, so that Cambridge has no room to argue and say like, oh, maybe this was a fluke or something like that. Okay, so really check with your teacher. Although personally, I always recommend my students to use the values okay, on top of stating the mode of measure, which in this case is the median. Okay. Now, part B, finding the interquartile range. So I'll do this in a different color. Okay, so the interquartile range for town A will be between these two values, which is 4,000 and 5,001. Okay, so town A IQR equals 5100 minus 4,000. That will give me 1100. Now for town B, the interquartile range will be between these two values, which is 6,600 and 546. 567894900. Hi Nigel. Yes, so sorry. I realized I was looking at the wrong lines. Something wrong with my eyesight today. Okay, so this is supposed to be um five into 5200 minus 4,000 and 6676700. Okay, so interquartile range for town A is actually 1,002. Interquartile range for town B is 1800. Okay, so that is our answer for part B. Hi Denise. Okay, so Denise says that in part A there is a lot to write with a like shock face. Okay, it's actually not a lot. It's just that I'm squeezing everything into one little column on my page. Okay, so it's actually, if you actually write it out on a foolscap paper, I don't think it should take more than 2 lines. It's just, yeah, one, 2 lines. Although if you look at the TYS, Cambridge will give you a lot of lines just to, yeah, just to make sure that you guys have enough space. Okay, yeah. Okay, then let's move on to part C. So, which town has families with income that are more evenly distributed? Okay, so this time they are asking about the even distribution, the distribution of data. Comparing distribution, okay, or spread. Another word for it will be spread. So when we are comparing the spread of two datas, what will we use as our mode of measure? What will we be comparing? Which key value of our five key values, which key value will we be comparing? Any clues? Any guesses? Okay, we will actually, here, I see we're running out of time, so I'll go a bit faster, okay? So we actually use the interquartile range. Okay, so that will be our mode of comparison. Okay, so between the interquartile range for town A and town B, which one is larger or which one is smaller? So obviously we can see that town A is smaller. So which one would you say is more evenly spread? Do you think it's more evenly spread if things are far apart or evenly spread if everyone is close together? If all the numbers are close together. So if I have plants that are between all 10 plants are 10, 10, 11, 12, 13, 14, 15 cm. Do, compared to another group that has plants 10 cm, 20 cm, 150 cm, and then some 20, 30. Which group will I say is more close, like more has a smaller spread essentially or more consistent? Yeah, I think the keyword will be consistent. So which group will be more consistent? Okay, it is actually town A. Okay, so families from town A have incomes that are more evenly spread since the interquartile range, okay, I'm going to use short form, but please, when you're writing out the explanation, please use the full word. The interquartile range for town A is 1,200 lower than than that of town B. Okay? Okay, so again, always state your answer and then your mode of measure, and of course, to really drive home the idea, okay, use the values. Is that clear? Okay, so why is it town A? I see some of you are confused. Okay, because again, so imagine I have two groups of plants. Okay, so one group is all around here. Okay, all the plants are around that same height compared to 1, 2, 3, 4, 5, 6. So I have 6 plants, and then I have another 6 plants, one like that, and like that. One, two, three, four, five, 6. Okay, so which one? Okay, let me just remove the last plant. Which plant will I say, which farm, okay, assuming these are plantations, which farm is more consistent? Very good, Denise. Yes, the first one is definitely more consistent. Okay, so when we are talking about more evenly distributed, we are talking about which one is more consistent. Okay, we are comparing consistency, spread or consistency. Okay, so we want a smaller spread. Okay, so the one with the smaller spread will be called more consistent, right? Smaller spread. Because remember, the spread is the difference between the plants. So the red part is my spread, right? Compared to this one, the spread is so big, right? So smaller spread, therefore it will be more consistent. Okay, I hope this is clearer. Okay, now bubble question 9, practice your application. Okay, so this continues, it's the same question. So now you have two classes, class A and class B, students from these two classes. So which class generally scored better? Okay, so they are asking about the general performance. Okay, you have 30 seconds for this. Your time starts now. Okay, so again, this question is on the general performance. Okay, we are comparing the general performance. So what will we use to measure the general performance? So to compare general performance, we use our median. Okay, so what is the median for class A? What is the median for class B? Okay, so the class A median is 70. Median in class B will be 1, 2, 3, 63. Okay, so which class scored better? In this case, better will be if the score is higher, right? So which class generally scored higher? That will be class A. Very well done. Okay, now continue. Which class performed more consistently? Okay, so now we are comparing the consistency. Okay, so remember when we are comparing the consistency, what do we use as our mode of measure? You have 1 minute for this. Your time starts now. Okay, so when we are comparing consistency, we use the interquartile range. Okay, so what is our interquartile range? For class A, it will be the values, okay, the range between our upper quartile and lower quartile. Okay, so that's 80 and 60. Okay, so our IQR will be equal to 20. Now for class B, our upper quartile and lower quartile values are here. So what is our interquartile range? So 75, 6, 7, 8, and 52. Okay, so the interquartile range for class B will be 26. Okay, so which class do we say performed more consistently? Okay, so remember, consistency is when everyone's scores are closer together, right? So we want a smaller spread. Okay, so if it's more consistent, so more consistent means a smaller spread. Okay, so we are looking for the smaller interquartile range, and that will be from class A. Okay, very well done. Very, very good. Okay, now there are a few bonus bubble questions that will be posted onto Genie Ask. Okay, so this one worth 30 bubbles, another 30 bubbles here, and another 30 bubbles. So altogether, it's 30, 30, 30, 90. Sorry, 90 bubbles altogether. Okay, that will be posted onto Genie Ask for you guys to try on your own. I highly, highly, highly recommend that you guys do this, especially for this chapter, even if you haven't done the other chapters, because this chapter focuses a lot on explanation. Okay, so the Genie Ask teachers will be able to help you through your explanation questions. Unlike in Genie Smart sometimes, okay, where the explanation isn't quite up there. Okay, now, and finally, tip of the day, understand how the key values affect the shapes of the cumulative frequency curve and the box and whisker plot. Okay, this will be important, especially in explanation questions. Yes, so I think I will go through a bit more of this later on after I end the class, because yeah, this is actually quite a big part in the O levels. A lot of, like, yeah, but I know we are over time, so I will leave that to the additional portion of our lesson. Okay, so those of you who need to go, you can go first. And just finally, a summary of what we did today. We recapped the 5 key values, okay, and we also learned about the box and whisker plot, okay, as well as discrete data. So that means individual sets of data. Okay, I hope this was clear to you guys. If you have any questions, feel free to send them in. Yeah, otherwise, I look forward to seeing you guys again next week. Okay, take care, stay safe, and bye bye.